Hi everyone, this is Hossein from EJ Academy. So today I'm here to review a calculus problem. This problem relates to applications of integral, and in this specific problem, we want to use integral to calculate a volume of a solid. So you see the problem statement on the screen. So we're going to find the volume of a solid that the base of the solid is a parabola. The equation for the parabola is y equal 1 minus x squared, and the base is confined by this parabola and also the x-axis. And then the cross-section perpendicular to the x-axis are isosceles triangles with the height equal to the base. So the cross sections means, if we cut a cross section like that, so the cross section is going to be isosceles triangle like that. And in that triangle, the height is going to be equal to the base. I also have a 2D graphs showing the base and the cross section. So on the left side, the red, in the red, you see the parabola. The equation is given, y is equal to 1 minus x squared, and it's on x y plane. And then, so the cross section perpendicular to the x-axis, which means if we cut a cross section like that, perpendicular to the x-axis, it's going to look like the shape on the right side. So it's going to be an isosceles triangle, and that cross section is in y-z axis because the z-axis is perpendicular to the xy plane. So this is our xy plane here. So x-axis and y-axis, and then the perpendicular axis to x and y is going to be our z-axis. So we are going to, so that the base of the solid is confined by this parabola and the x-axis. It means that this is going to be the base of the parabola. So I'm going to shade that here. And then the cross sections, for example, if we cut the cross section here, so that cross section is going to look like this triangle on the right side. So let's go ahead and find the volume of this solid. So I know that on the right side here, I'm looking at the cross section, and the blue line is basically the base of this triangle here is the same as this blue line here. So the base, I'm going to let's call that B. So B is the base, and then that base is equal to, well, we know the coordinate of this point here. So this point here, the coordinate is y, which is equal to 1 minus x squared. So that point corresponds to this point on the right side. And then, so this point is y equal 1 minus x squared. And we know that this cross section is at a distance x from the y-axis. And then the height of this triangle, let's call that h. And we know that height is equal to the base that is given. Okay, if I wanted to use integral, if I calculate the cross section and then do the integration from, you know, all the way from this end to that end, then it's going to give me the volume of this solid. So what I'm going to do, my strategy is going to first calculate the area of this this triangle here. So I'm going to calculate the area of this triangle. Let's call this A. And then after that, I'm going to use integral to just, integral is basically a summation of all these areas. So I'm going to have a triangle here, a triangle here, a triangle here, here, all the way to the other end. So I'm going to use integral to just add all these areas from here all the way to here. So the area of this, you know, any arbitrary cross section, A is, let's call it the area of an arbitrary cross section at a distance x from the y-axis. So we're looking at any arbitrary cross section at a distance x from the y-axis. So you see that cross section here, this is a general cross section, and the area of that cross section is going to be equal to 1/2 of base times height. And the base and height are given. So we know that the base, so the base here is equal to y, which is equal to 1 minus x squared. So I'm going to use that information. I'm going to plug those values into the equation for the area. So 1/2 times b is equal to, so I'm going to write here h equals to b equals to y, and then y is equal to 1 minus x squared. So I'm going to use that and plug those values here. So b is equal to 1 minus x squared, and then h is also equal to 1 minus x squared. So the area is equal to 1/2 times 1 minus x squared squared. Now we need to use integral to just add the area of all these arbitrary triangles from this point to this point. And by the way, you know, these 2 points are the roots of this equation. And the roots, so I assume you already know how to calculate the roots of the parabola. I'm not gonna, you know, go through the calculation of the roots in this video. So, so this point here is -1, and then this point here is +1, and then the -1 and +1s are the limits of our integral. So we're going to do the integration from all the way from -1 to +1. So the volume is equal to the integral from the integral of a times dx, a times dx from -1 to 1. And then because this is a symmetric shape, so I'm going to do the integration only for 1/2 and then multiply it by 2. So I'm going to say 2, this is equal to 2 times integral from 0 to 1, a times dx. And then if I replace a with this equation up here, I'm going to have 2 times 1/2 times 1 minus x squared dx. And then these two outside and this 1/2, they cancel out. And so I'm going to have v is equal to integral from 0 to 1. I think I forgot to put the limits here, 0 and 1. So integral from 0 to 1 minus x squared dx. So I'm going to expand this. So on the side, we know from algebra that a minus b squared is equal to a minus b times a minus b. And then if you expand this, if you do this multiplication, you're going to get a squared plus b squared minus 2 times a times b. So this is on the side. So I'm going to use this. So I have integral from 0 to 1. So first term squared plus the second term squared. X squared minus 2 times 1 times x squared dx. And then if I simplify that, I'm going to get integral from 0 to 1 plus x to the fourth minus 2 times x squared dx. And then this is an easy integral to solve because we're going to use power rule. And so the power rule is for derivative, but the integral is the opposite of that. So I'm going to write the power rule on the side. Power rule in derivative says that if you want to take the derivative of, let's say, x to the nth with respect to x is going to be n times x to the n minus 1. And then for the integration is going to be the opposite. So the integral of x to the n dx is going to be equal to x to the n plus 1 divided by n plus 1. So I'm going to use this rule here and solve this integral. So v is equal to integral from, I think I should remove the integral sign because I'm going to solve that. So the integral is going to be integral of 1, the first term is going to be x. The second term is going to be x. I'm going to add to the power x to the fifth divided by 5 minus 2 is the multiplier, and then x squared, the integral of x squared is going to be x cubed divided by 3. X cubed divided by 3. And then the limit is from 0 to 1. And so if we, this is a determinate integral if we put the limits. So I'm going to have 1 plus 1 to the fifth divided by 5 minus 2, 1 cubed divided by 3 minus, so if we put 0, all these three terms are going to become 0. So 0 plus 0 minus 0. And then if we simplify that, so the terms in the first parenthesis, the common denominator is going to be 15. So I'm going to have 15 here. So the first term, 1, I'm going to multiply that by 15. The second term is 1 times 3. And then the third term is going to be 2 times 1 times 5. And this is going to be 15 plus 3 minus 10 divided by 15, which is equal to 18 minus 10, which is going to be 8 divided by 50. So this is our answer here. So basically, to recap, I calculated the area of an arbitrary cross-section here based on the information given in the problem, and then use integral to sum all the areas all the way from this point here to this point. So I had many small areas, and I use integral to add all these areas, and then when you do that, so you get this value at the end, which is going to be the volume of this solid, which is base is a parabola, and the cross section, any arbitrary cross section, is a triangle, which you see the apex of that triangle here. So in the next video, I'm going to show you how you can use Python, one of the libraries in Python, to draw this 3D shape. It's going to be a cool video. So until next video, if you have any questions related to this problem, you can leave your questions in the comment section below this video, and I try to get back to you as soon as possible. And if you haven't done already, please subscribe to our channel to support us, and also get notification whenever we have a new video uploaded into our channel. Until next video, bye everyone.